Hello, aspirants. It's nice to see you all again. I'm very sorry for not posting in months. I'm afraid that I was very busy working and then relaxing during my summer holidays, and also my computer broke down and I had no way of editing, and I was planning to actually release this video at the start of September before school started, but how things went on, that didn't happen. However, I am back. There will be more videos to come. Yay! I will be looking for what you guys would prefer. If you guys want past paper walkthroughs, doing some fun experiments and seeing what we get, some other kind of videos, I'll be looking for suggestions. But this video is all about back to school. Firstly, congratulations to all of the students that finished their GCSEs and are now studying your A-levels. To all of the year 12s, congrats on now reaching year 13. Just one more year to go and we've pushed through. And to all the year 13s who have graduated, congratulations on finishing your A-levels. And I hope you guys have fun things waiting for you ahead, whether it be university, work, or anything else. In honor of the new school year, today's video is all about the math modules that we have in year 12, because now I have completed all of them, so I'm here to tell you guys which ones I think are my least favorite to my most favorite, and see if you guys agree with me. These are, of course, personal opinions. Don't take them into account. Maybe you might have complete different opinions and you might absolutely love the ones I didn't like that much, or you might hate the ones that I found the best. But it's of course, everyone's entitled to think their own way. But this will just be my sort of disclaimer to anyone starting year 12 and giving a short rundown of what each module contains. For my year 12 maths and further maths course, I did a total of 6 modules, 3 in maths and 3 in further maths. These included Pure Mathematics 1, or P1, Pure Mathematics 2, P2, Mechanics 1, M1, Statistics 1, S1, Statistics 2, S2, and further Pure Maths 1, FP1. Depending on your school, you might do them slightly differently, but I will now be doing 6 more modules in year 13, and maybe I'll make a video about that once I finish those as well. I'd also like to mention to anyone who is now in year 12, if you have picked the same AS courses as me, which would have been math, further math, physics, and chemistry, I would like to give you a short message. Would you like to talk about why you hate yourself? This is a safe space. To start off the list, we're going to go with the least favorite in the lowest spot, Stats 1. I have no hatred for any of my math modules. I love math. I'm a big nerd. Stats 1 is the only one that has a little bit of hatred. I enjoyed all of them, but this is the only one that has some disliking to it. The rest of them are just in order of preference. This one will go at the bottom because I actually didn't like it. It was... I could rampage about this thing all day. It's about things that we've been doing since like year 8 that we should already be accustomed to and we shouldn't have to worry about. It's got the most random questions. It introduces some good topics later on, like we look at what linear regression is, which is basically just taking a bunch of points and finding the average curve for it, which is great. You can do that in a mathematical way. It's not like in physics where you approximate it. Now you can do it mathematically, but still, that doesn't seem like that much. And then we learn about rolling dice, and if they're biased, what's the probability of that happening? There's no point to go over this. We've been rolling dice since kindergarten. Probably the best thing that has salvaged the whole thing, the only thing that is really important in S2 was probably the normal distribution. And don't get me wrong, in S2, of course, you require all of your stats knowledge, like what range is, what mean is, but we've been doing that for years. We don't have to go over that again. It's not something you should be doing in A-level by now. It's normal distribution, which is a curve which describes a lot of different relations and how things are spread out in nature, in our whole universe. That's useful. That was interesting. It's quite difficult. And in our exam, this was one of the more difficult things, at least for me. But it's still probably the most useful thing that you learn in all of Stats 1. The rest, I didn't learn anything because we knew it all for like the last 5 years. But oh well, I guess That's what you have to do. You have to get through the basics. It did teach you some good notation. I'm going to give it that. Like, we learned about how they professionally write a lot of statistic things, the probability of something happening, the symbol for the mean, Q1, Q2, a bunch of other cool stuff. But that's it. Another thing I didn't like about this module is, as much as I thought the normal distribution was the best, I don't like that it's a table of values they give you in the formula booklet. Like, I feel like there should be some more mathematical sense than, like, okay, I did the calculation, now all I have to do is find out where this value is and find the corresponding result in my table. Which, I guess, okay, that it does make sense. It's a complicated equation. You wouldn't want to integrate that during the exam, and I sure wouldn't want anyone to have to go through that. But I'm still preferring the idea that you can get more exact values, not just reading off a table. But that's one thing I can let slide. That's okay. It's more everything else I said. I don't have it. I don't have many positive things to say. Those are my cons, and then the pros: normal distribution, professional notation. That's it. Lowest on the list. That's all I can say. To all the people that are doing S1, it's not as bad as I make it. If you have your mock exam as June 2025, I pray for your soul. Maybe I'll go through it one day once it gets released in general. I don't know when that is. But I can't keep talking about this for another like 20 minutes. So let's move on to the next one on the list. In fifth place is Pure Maths 1, P1. Now, I don't really have anything against P1. P1 was a good module. It was quite a nice step because once you come back from GCSE maths, it has a lot of overlap in the first few chapters. And like I was saying with Stats 1, I feel like there's something that we could have skipped. Like, you'd be expected to know maybe by now. But I think it was good to get a refresher, especially after the summer holidays. Um, Especially on the things that we just did in like year 11 and maybe year 10. But once again, with stats, that's been going on for like the last 5 years. We don't need a revision of what a mean is. But I digress. Pure 1 was pretty okay. There wasn't a lot of new content. Like I said, it was a lot of revision of old things and building a little bit on them. I really enjoyed the fact that we learned what radians are, which is a different way of measuring angles instead of the 360 degrees that we're used to. And it's quite a nice and elegant way once you get used to it. And we also finally learn what integration is, which I think is also great. Though we don't do a lot of integration in P1, it's still great because it gives us the foundations and the necessary start that we need for later in the year when you do pure maths 2. Overall, it's just a good base. It gives you a base for all of the rest of the modules, so it's a nice module. But compared to the other ones, it wasn't that interesting because it was the base. It kind of helped make the other things interesting. So shout out to being the supportive friend of the math modules. But it wasn't, there's nothing much to say about it. In fourth place, I'm actually going to say mechanics. Now this is going to confuse some people because I know that a lot of people didn't like mechanics, at least in my school. But I do actually put it quite higher compared to Stats 1 and Pure 1. Mechanics was also pretty interesting. It's quite okay. It's very nice if you're doing physics as well because there's loads of overlap, especially in the Unit 1 of physics. And that's great because it helps you to build on both areas. It really did help me get a deeper understanding on both of those subjects then. It was overall quite interesting. I think that the vectors that we look at, it's much more physics. It's not really like the mathematical vectors. You do have to split it up into components. You learn how to draw force diagrams, which is quite useful in the exam, even maybe in a physics paper, but usually they give you a sketch. But physics is a conversation for another day. Mechanics was, it was okay. There wasn't much that was new as well, especially if you're doing physics. I think that there was so much overlap that at one point you realize, oh, I know this. Oh, I've heard of this before. I've seen this. But it's about doing it more in a mathematical sense and focusing a lot more on the math side, not just the physics explanation of the universe and all of that. The trickiest part about mechanics is not forgetting something like, is there friction? what kind of forces are acting on it, what's the component of the weight if it's at an angle, and all of that. But it was a pretty okay module. It was the most interesting one because it did have a lot of overlap, like I said, with physics, so it's things I'd seen before. It wasn't going to make me wow, but it was still interesting, and I'm very glad I had it. Which brings me to an important thing. If you're not doing further maths, you'd have to pick between mechanics and statistics. So it's more likely that if you pick mechanics, you're doing physics or something along those lines, and you plan to work in engineering, architecture, somewhere maybe that direction. But if you're doing statistics, you could do anything else. Maybe you're doing biology, because it helps you to analyze how different ecosystems work. You might be working with finances. There's a lot of different areas for statistics, and the same goes to mechanics. However, I feel like in this case, statistics is more broad, but I still did find the mechanics module more interesting. Perhaps that has to do with the fact that I'm more of a physics person when it comes to the maths. I'm leaning towards the physics side than the financial side. But of course, like I said, everyone's different, so make sure to tell me which you would rather do, stats or mechanics. Third on the pyramid, we have Pure Maths 2. This module was very interesting, and I did enjoy this very much because we finally got to look into quite a few new areas of Math 2. Like almost every single Pure module, it started with some form of algebra and remembering how to move fractions around or something like that. But then after that, we look at coordinate geometry and new equations for circles, how we can represent them in the XY plane, which was really interesting. I did enjoy that because it did give me a better understanding on these different new equations which I didn't think of before. Even more exciting, we looked at exponentials and logarithms, which is something I'd heard a lot about before and I'd seen loads about. We might have done a little bit of exponentials and logs before, but logs definitely not. And it was interesting to finally understand and learn how they work. And after some practice, they do feel quite easy and like second nature once you know all of the rules on how to use them. Along with that, we also learn about the binomial expansion, which was a very interesting topic, and it makes a lot of things much easier, especially when it comes to expanding brackets. And if you do stats 2, this becomes very helpful to you too, and it helps build your understanding. I feel that the pure maths modules, P1 and P2, were definitely a good basis for any of the more specific modules, especially P1. P2 has a few of its own things and a few of its own quirks, which was very interesting, but it does help to build with the other modules, which is great. Then we look at arithmetic sequences again, which is something that we had seen a few times, including in GCSE, but we also look at geometric sequences, which are a new type of sequence that you'll learn about later. And they were also quite interesting. I did enjoy them. It wasn't the highlight of my P2, but it's something new to learn, and I did find it quite fascinating. Then the last few chapters was first you had trigonometry, and then you had calculus. These are some of the biggest topics in pure math, and they make a lot of people's brains hurt. Firstly, about the trigonometry is having to find out how you can rewrite a certain trigonometric expression, something with a whole bunch of sine, cos, and tans in it, and then somehow simplify that. That's something that you have to do a lot of then. At the start, it was quite difficult to see the connection on how you would go from one way of writing to it to simplifying it into another. But after doing quite a few exam practice questions, I think that it did come more clearly. If this is something that people struggle with, I'll make sure to maybe make a video on it. But I do think that I did see students finding it easier after a lot more practice. Overall, it was okay. This differentiation topic was quite similar. There wasn't a lot of new tricks and tools to differentiate. You just learned about doing it twice and what effect that has, which I thought was interesting because I wasn't actually expecting that. Considering that usually I learn a lot of maths and then I understand how it works. This one had an interesting way of somehow shocking me at first. Like I wasn't expecting this. When we looked at how doing a double differentiation can tell you where the gradient is zero, what that means about it, or things that you'll see and will make sense later. I'm trying not to explain it because I don't want to teach it to you today. I You'll be doing that later on anyway. It's just sort of my own opinion. I found it a little bit surprising, even though there wasn't much to learn. Maybe that was just me because I was delving into the details of how the maths was working. So if you guys don't see it that way, that's perfectly fine. I might just be cuckoo for maths. And the most exciting part about all of this is we finally used integration for what its purpose is. Because in P1, all we learned to do is how to integrate the steps necessary to do integrations of powers. Just like we knew how to differentiate powers of x, we now know how to integrate those. But now we know what it's useful for, and we're able to actually solve questions and use integration to find answers. Not just a simple tool, it's not something we can actually take out of the toolbox and make something with. Which I thought was really, really cool. It was one of my favorite parts of P2 is that it finally has a purpose, because you hear all these people talk about calculus, integration, differentiation, these big words, and then we finally learned how to do it. So it felt like a personal big step forward in maths, where you finally learn one of those big things that people are always talking about. Now I finally know what integration is. And I thought that was great. So that's why I think I put P2 so high up. It was quite an interesting module, but I think that the top two do really take the cake. In second place, what I think some people will find surprising, I'm going to put Statistics 2, Stats 2. Because this module is actually very, very interesting. And I enjoyed it so much. I could ramble about this all day. I probably will. This module took statistics, saved it from stats 1, and actually did something useful with it. You learn about more kinds of distribution, about how things appear in the natural world, not just a normal one. You learn two more different ones. And you can learn how, if it's difficult to solve one, you can use another one to help you get a better understanding by approximating. You learn how these can be used to solve real world questions, test a hypothesis. Is this true, or might there be an actual different answer to this? You also use integration in this module, which I thought was great, because you look at how instead of just picking numbers between 1 and 6 on the dice, you can also now pick the decimals. Any possible number between 1 and 6, 1.5, the square root of 2, pi, anything like that, you can now have what's the probability of getting those values. And I thought that was much more interesting, because now we have an even bigger range of tools for S2. That's something we didn't see before. We didn't know we could use integration in Stats 2, but now we can, and I thought that was great. And we can test hypotheses using this, looking at, is this true? Maybe I should test. Maybe the values have changed over time, and I look, oh, this is not supposed to happen. Maybe my readings were incorrect. You learn how people actually use statistics in real life. People aren't just calculating means and ranges all day. They're actually using statistics to find out how different things change. People are predicting the weather using statistics. And it isn't based off of calculating the mean by adding all the values up and dividing by how many there are. It's by using these distribution models and all of the things that you'll learn in S2. And I think that's great, because it's actually useful. I mean, S1 was also useful, but this was really useful and really interesting as well. Now, stopping with the rant on statistics, let's get to the top module, the one that takes the cake, the best one from all of my modules in year 12 was Further Pure 1. I loved Further Maths Pure 1. It was so, so good, and it was the first module I did for my Further Maths course, and it sealed the deal. I was like, I know I made the right decision picking Further Maths, because it was pure maths, one of my favorite forms of mathematics. Basically, maybe even my favorite way of learning maths was pure maths, and now we're looking into much more interesting and important areas of pure maths, like complex numbers, matrices, proofs, coordinate systems, all of these things that appear everywhere. How computers work. Computers are based off of this. Engineers use complex numbers all the time. The coordinate systems we use are shown in real life architecture. and proof, which is probably one of the most important areas of maths, especially at university level, knowing how to prove something. Because if so, in the maths, if something's wrong, it's wrong, and you're getting bullied for it. Like they're going to make fun of you. It's like it's a popularity contest of who is making the most true statements. Like if you want to defend your point and show that this statement is true, you got to make sure you're fighting for your life to prove that point. If there's a single mistake, they're going to deny everything and throw it out. So knowing how proof works and starting proof, especially with such an elegant way of doing proof, was one of my favorite things in Further Pure 1. I really enjoyed it. My only complaint on Further Pure 1 is numerical solutions, because I like the idea of getting exact answers. Like that's the whole point we do math, is we're looking, okay, what's this? And then like you get your answer and you're leaving it in the form of pi, because or the square root of 2, because you want to have it as exact as possible. Then if someone wants to get the decimal version, they can, and they can pick how inaccurate do they want it to be. Like, will they do 3 significant figures or 2? But if you just give them 3 significant figures, maybe they wanted 4 and they won't be able to do that. That's why math is great, because we're always looking for exact answers. But numerical solutions does the opposite of that, because what it does is that it's too complicated to solve this equation for whatever reason. So what we do instead is we're looking around the answer, like the answer somewhere in the middle here, and we're going to step by step get close to it, approximate it. We're going to put some values in our calculator. Oh look, that's getting close to the value I want. I guess it must be something like that. But it's not rigorous. It's not like a completely accurate answer. So that's probably my one complaint, is it's useful for checking if you got the right answer and all of that. Oh yeah, it seems like it's right. But it's not very rigorous. I don't know. I didn't like that part so much. But I have been doing some research into numerical solutions, so maybe I'll warm up to it and realize its potential and use later on. I'm not an engineer. I don't round pi to 3, okay? As much as I love physics, I am not doing that. We love pi equals pi. That's the final answer. There's no debate. If you comment something against that, I'm blocking you from my account. I'm sorry. And there was also series, but like it's series. There's not much to say. Yep. Sum, sigma, whatever you guys want to say. That's about it. That's the entire FP1, and it was great, and I love it with all my heart. And now that I'm doing FP2 and FP3, I see how calm and sweet it was. What a beautiful child. How innocent I was back then. But that's how life goes. I really did enjoy your 12. So anyone who's doing any of these math modules, do not be strayed. I know I did complain a lot about S1, and I complained a little bit about the other ones, but it's all about the learning process. You're going to have ups, you're going to have downs. You just have to keep working for what you enjoy and what subjects you are going to want to do. It's all about you doing what interests you. So I hope you guys do enjoy your time in A level. I hope you do take advantage of that opportunity, and hopefully I'll be able to help you guys on the journey, making a few videos every now and then if my computer no longer breaks down. But thank you so much for watching today, and I hope to see you guys soon. Have a nice time at school, and happy back to school.